1998, number 91. So the first thing we see that we have differentiability from 1 to 10. All right? And so if it's differentiable, therefore we also know it's continuous. That's an important thing to know. So if something is differentiable, it has to be continuous, because we know something's not differentiable if there's a sharp point, if there's a vertical tangent line, or if there's a discontinuity. So if there's a discontinuity, it makes it not differentiable. If it's differentiable, it must be continuous. Okay, so we have f of 2 is -5. F of 5 is 5. And 9 is -5. So they want to know, does f have at least 2 zeros? And it's pretty obvious to see. If you have a continuous function and you go through these points, you're going to have to cross the x-axis twice, okay? Because it's continuous. No holes, no jumps, no gaps. Now, could it cross more? Yeah, it could cross a bunch, as many times as you want, but at least twice, because you have to cross going up and you have to cross going twice. That's an intermediate value theorem. So first you do the intermediate value theorem between these 2 points. Let me get a different color for you guys. Intermediate value theorem says if you have a continuous function, the function must equal every value between these two, and 0 is between that. And then if you use the intermediate value theorem between these 2 points, the same thing, you have to cross every value between these two, which 0 is, so you have to cross 0. So that's actually applying the intermediate value theorem, so that is true. The graph of f has at least one horizontal tangent. Okay, that also is going to be true. So let me tell you why. And this is going to be using the mean value theorem. If you find the slope between these 2 points, so that's going to be f of 9 minus f of 2 over 9 minus 2. And if you simplify that, you're going to get -5 minus -5 over 7, which is 0. So clearly the slope between these two is 0. This is the mean value theorem. Okay, I forgot to point something out. We're going from 1 to 10. 1's over here and 10's over here. I should say it this way. 1's here and 10's over here. So it's differentiable between these 2 points. So therefore, it's continuous and differentiable between those points, which includes from here to here, because we need continuity on the closed interval for all these to work. And since inside of these 2 points are 2 and 9, it's continuous and differentiable on the closed and open interval for both differentiability and continuity. So we're good with the mean value theorem. And the mean value theorem says if you have continuity on the closed interval, differentiability on the open interval, then there must be a point, at least one point between 1 and 9 where the derivative equals the average rate of change. That's the mean value theorem. So the derivative must equal 0. That means it has at least one horizontal tangent line. So that statement must be true using mean value theorem. The fact that the derivative must equal the slope between the endpoints if it's continuous on the closed interval and differentiability between or on the open interval. All right, so from 2 to 5, here's 2 and here's 5. Does the function have to equal 3? Well, this is -5 and that's 5, and 3 is between it, So again, by the intermediate value theorem, you have to cross 3 at some point between 2 and 5. So that statement is true. So we got all three statements. So the answer is E.